Hi everyone. Sorry for the delay. Uh, it is 4:30 a.m. in California, and I put my alarm, but unfortunately it didn't work. So that's what happened. Let me start the session since we are already behind the schedule. Let me share my screen. Okay, hope you can see my screen. Yeah, today's topic is about agility and how we can achieve true agility through the programmability. That's what we are going to discuss during next 30 to 45 minutes. So before jump into the topic, I'll give a quick introduction about myself. So this is about me and my career line. So I started my career as a C++ programmer and then did a lot of Java development when Java came into the picture, and started a small software house building a hedge fund tool after that. And then I joined WSO2. That's my current employee. I joined WSO2 in 2008 and worked in many product engineering and product architecture teams, and then moved to more external facing technical role with the solutions architecture team. And today I am telling the WSO2 story as the chief technology evangelist. So if you notice, I was contributing to open source for a long time, as well as working on distributed computing from day one. So let's look at the agility. So this is a nice statistics that I found from this particular report published by 12 State of Agile report. And if you look at it, a lot of organizations are moving with agility, but unfortunately around 4% only getting the full benefit of agility. So that's a very unfortunate situation. And as a consultant, I am working with many organizations, and I am seeing the same inside most of these organizations. They are working on these projects, but unfortunately, they are more moving to waterfall agile or agile type of model, not true agile that we are looking at here. So it is just like this kind of powerful car that is running in not running on a unstructured road. Is just like that. The teams are practicing agile principles, but they don't have a proper environment or proper outcome from these principles that they are following. So actually, to get the full benefit of agility, they need proper environment, a culture, and a lean framework to achieve that. Like you run a powerful car in a proper environment, like you see in a picture. So not only the car, not only the road, there are many other reasons behind this. So one key reason is the team. So there should be a proper team who will be working with a very connected way and contribute accordingly with their skills as well as their role in this team. So that is another dependency to become true agile. So if you look at the agility, it's all about the developer flow. So as a developer or a technical person, what you will see that you to have interruptions, that you will have to you would like to be productive as a developer. Developer will like to check out the code, edit the code, write a new code, test it, commit it, and then deploy it. So that particular cycle, they like to do it continuously without having any interruptions. But unfortunately, it's not the case in many situations that it is basically the individual productivity as well as how the entire team will have a proper synergy and they are connected and providing output together. But this flow breaks in many cases. One example is this, like we as developers, like we have to join for different type of meetings, and then these meetings are running very late. Even after pandemic, now everybody's got used to online meetings, and these kind of unwanted things are disrupting developers heavily. Another reason is organization structures. Like most of the organizations are layered, and layers creating gates. The architecture is layered as well as because of the architecture is layered, these teams are operating in a very layered fashion as well. So with that, as a result, what's happening even within the team are practicing agility, it will become more waterfall agile. So the people talk about center of excellence teams. What will happen with these center of excellence teams is it will create a new silo and then slow down the entire flow of these teams and their productivity. So it's a nice tweet that I found in the internet. Then Donnie tweeted about this thing. You say center of excellence, and I hear a new silo, and this is very true. Another reason for agility is one blocker for agility is this complex interruption flow, so the complex architecture. So that's why one reason for service-oriented architecture wasn't very successful, because by design it created layers, and as I explained in the previous diagram, layers are creating a blocker. And even if you look at most of the architecture, the designs that we used are layered as well. So that is kind of pushing people into this very siloed operating model, as well as it is creating gates, as I explained earlier, and slow down the entire flow. So this is about the Agile Manifesto. Agile Manifesto is a very nice system that they have defined the principle. But unfortunately, most of the agile methodologies available are very heavy. They are not agile by itself. So that's the main issue. And organizations are blindly following agile methodologies without taking most important things from each and every method. So that is one issue that we see in the markets. So let's look at the programmability. Now we have two areas, right? One is the agility and one is the programmability. But I did earlier look at the current landscape and happening with agility. So let's look at the programmability. So programmability, if you take a standard definition, it's basically ability to connect physical and digital. Basically, how you can connect a physical device or how you can enhance a software system with another software is what we call the programmability. And it started long time back with the devices. Like if you look at the logic devices, those things started with standard logic devices, and then it came with the programmed logic device, like the program was inside, you was like you couldn't change anything. That's where the microprocessors and microcontrollers came. And then the programmable logic devices came into the market. Again, simple programmable logic devices like PAL systems. And then in today we have the high density programmable logic devices like CPLDs and FPGAs, so and so forth. So that is how this started. And I think if you can remember in early late 90s and early 20s, interested about programmable devices, and I can remember we started programming a refrigerator when a refrigerator provided a small API with using Java, and you should be able to do some communication with that. And if you can remember the network devices, was very interesting. These things came into the market that we started working on this stuff. So another diagram about the history, how did it happen and how the evolution went through different stages, and these devices came into the market after that. So networking, as I explained, it was a very popular thing that network devices started enabling programmability, and we got a lot of benefit out of these devices with the programmable nature. Even if you take a router, like you can do a lot of programming using scripting languages and enhance the capabilities of these devices. So then the infrastructure level programmability was very popular, especially when infrastructure as a service solutions came, and those provide many ways to program it, like using a different type of infrastructure as a code, like Chef, then even languages like Go, TypeScript. We started scripting these deployments, and then even logic, like how we can scale a deployment, so and so forth. And all these mega clouds like Amazon, Google, they provide these capabilities to do that. And today it's a world of Kubernetes, and as you know, Kubernetes is highly programmable, that you can do many things to a Kubernetes cluster by using these scripting languages. Even you can change the behavior of a Kubernetes cluster by introducing set of programs to it, and get the output as you are looking for. So that's about program. At a little bit about the application architecture. So this is a layered application architecture. And when it comes to the layered application architecture, you can see different type of layers horizontally and vertically. In this example, it is going from data to data layer into a presentation layer with many other layers, and you can see all the quality of services in side by side. But the landscape has changed a lot, and today we see a completely a distributed architecture, because happen with microservices and these cloud native infrastructure layers like Kubernetes. So in the today, many architecture, application architecture systems looks like this. Everything is distributed, and you will see things and moving inside the infrastructure and connecting with outside components using API. So APIs is the way these things communicate and connect. And APIs are very important today. The definition of the API is programming interfaces, and a company without APIs is like a computer without internet. So that is the effect or the impact if you don't utilize APIs. Then the application programming interfaces went through evolution as well. So this is the progressing path. Isolated monolithic apps move into more microservices architecture, and then pure technical APIs, semi-technical APIs, and then into managed APIs. And now we are in the days of API products that utilizing this API. So as I explained, this is the glue. And if you look at the layered architecture, this is how each and every layer will connect with APIs. And you can categorize these APIs into utility APIs, domain APIs, and edge APIs. But what I want to highlight, each and every layer will connect and communicate using the APIs. Even the same concept, distributed architecture, also connect using APIs. Each and every component will expose API. It can be a domain API, it can be a utility API, or it can be an edge API exposed by the component, and using that API exposed, other components or applications developed at the top can communicate without any issue. So that is how the programmability we see in the industry. So this explains detailing So I have generated bunch of reference architecture documents. I have put the Git repo as well. And if you would like to read more about the decentralized architecture or layered and segmented architectures that I put in the diagram, you can read these specifications. All these specifications are released under Creative Commons, and feel free to contribute, criticize, or enhance these specifications by sending a pull request. So let's talk more about agility and how these concepts are connected. We so far discussed the issue with the agility, with the layered architecture, and then we discussed about the programmability, how it started with devices, and then how it is influencing the application architecture using APIs. But when it comes to the true agility, automation and having different type of build pipelines is the main or key component. And you can see a relevance here as well. Now, if everything's supported by an API, you can easily connect those components into the pipeline and make it as part of the pipeline that you are already running. So that is how this will help to enhance the pipeline and connect to a pipeline. So when you are picking a tool, you have to look at whether it's a programmable component. Like even when you are picking a product, you have to choose a programmable product. Otherwise, you will be not able to successfully enable it inside the pipeline. And pipelines are helping to automate most of the repetitive tasks. So we don't have to pay attention or spend time on those tasks, that we can let the build system to work on these tasks, and then we can spend more and more time on more innovative things and new things by letting the pipelines to handle all the repetitive tasks and take care of it. So that is the beauty of the automation, and how when you have pipeline. So programmability through API is increasing the automation, as I explained earlier, because any component that supports the API becomes as part of your build pipeline and take care of the capabilities without having any human interaction. So that is how powerful this. And if you look at larger deployments and most productive teams, automation is the key, and they have many pipelines, and I call it as the pipeline tune. Even when you're starting a new project or a new development, you will start by running a command. It will create your sandbox environment, get all the dependencies, connect with the supportive systems, and make you productive without spending a number of hours or number of days building this sandbox environment that we see as a common problem we face in day-to-day development. So you need a methodology. That's another thing. Now you have the concept, you have the capabilities of these components through the APIs, but you need a methodology. So I spent some time on defining a methodology as well. So let's take a look at what kind of things that I have listed over there. So methodology is just like a GPS that you will use to find a location, because you need to find where you are today, and then you need to define where you want to move. So the methodologies went through a different timeline as well. Started with waterfall, move into more spiral, and then Scrum, rational unified process, rapid application development type of concepts came. And now we have many other methodologies like TOGAF and SAFe. But my advice for most of the organizations who's working on agility to find a lean agile principle that is relevant for the organization, rather than stick to these heavy different type of agile methodologies. So my methodology that I have enhanced it from a traditional methodology. Usually methodologies talk about people, process, and technology, but this will go beyond that and then talk about the culture, architecture as the foundation, and then it takes the outcome as a digital alignment. So that is how the entire structure has done. Addition to that, the methodology contains a maturity model as well to see whether you are fully agile. It is a two-dimensional maturity model that identify where you are in this particular model and take necessary actions to move to the right. So idea here, you will be not equally even in one uh, dimension, that you will be enhancing few but might be running behind in few areas. So you can do a proper assessment and identify where you are and try to move to the right is the approach. We are not expecting you to move to the rightmost corner overnight. It's an iterative process that you will plan, review, and improve this particular journey. And it's a journey, so you will iteratively transform into your right, and you will be more agile with that process. So that is what we are expecting here. So it is a as I explained, you will most of the organizations at the waterfall agile level, then they will move to a API driven model and then increase the programmability and move to the early agility. But the state that we would like everybody would be in called the most agile state that we saw in the diagram, basically with these characteristics like pipeline tuned, multi-environment based application life cycles, and then test-driven development, and all the tests are automated and be part of your pipeline, and utilize the concepts, cloud native engineering and technologies, and use open source as much as possible, and decentralized architecture that they follow. So once we have all these characteristics in your environment, you can be more agile. And this is what we envision in that particular mode, a cellular enterprise that I call, that everybody worked in distributed manner and each and every team is responsible for plan, build, test, and run, and they connect each and every cell using API, and everything is programmable and everything is pipeline tuned. So that is the envision that I call it as a cellular enterprise, that how you can take some of these technical concept or technological advancements into business side of your organization as well. So I wrote a nice article about this concept, and if you are willing to or to dig in deep, you can read this architecture about the cellular enterprise that I published in Forbes, and it will give more insight for you to implement the same. So as an organization, even we are following this that we operate as a modular organization, and then the line of interactions we have moved towards the customers, and the iterative development model, as well as having many checkpoints to detect the success as well. Once you have a proper agile environment and then increase the programmability, you would like to measure your success as well. So how you measure your success is what we are looking at here. So if you look at multiple methods that you measure your success, the first and most important formula is the flow efficiency, because if you looked at the layered architecture, the wait time is really high. You had to wait for another team to help you or get something done. But when you have a programmability and high agility, you will have a less wait time and more productive time, so you will have a higher flow efficiency in your organization. So it's a really good way to measure and improve. Then the second option is about mean time to repair. So how, or we call it as MTTR. And there's another associated formula with MTTR called mean time to detect. So it basically explains you how quickly you can fix something and put it into production, or how quickly you can introduce a new capability or a feature and then put it into production, is what we identified in mean time to repair. So I rushed a little bit since I was behind around 15 minutes. So if you look at what's really happening today, is on a journey towards agility. Like everybody talking about it, every project manager talking about it, every team talking about it, and every executive talking about this as well. And the organization need to catch up with the project agility, because these are very interconnected. Project agility or the team's agility is affecting that product agility, and then the product agility affecting the overall organization agility as well. So it has a kind of a cascaded effect, and if the project agility is, or the team agility is not happening, you will not get the full agility of the organization as well. So the self-organized teams, or two pizza teams that we call, is one key reason to have proper agility, but these teams have to be interconnected properly within the team, as well as between each and every teams. That's where the technology concepts like APIs will coming in handy. If you have an API marketplace, you can use it as a way to communicate with each other. And then the architecture has to be decentralized, or we call it as a composable enterprise or a cellular enterprise, that when you have a proper decentralized architecture, you can increase the agility, make each and every team empowered, entrust, and engaged, as well as equipped. So that way they can be independent, but be responsible for what they are doing, and provide capabilities. And I was iteratively telling about, repeatedly telling about this programmability, so they can have a proper programmability, and then automate everything and increase the agility. And APIs is the foundation for programmability. Create APIs, expose APIs, and enable your capabilities to other units, and then look for APIs more and more, and then try to capture these capabilities from other teams, and utilize them as much as possible. So you will be reusing without reinventing. And when you are picking a tool or a technology, look about the API support and pick the tools which is supporting APIs as well. So in summary, these are the advantages that you are getting with programmability. Programmability increases the speed, because now everything is automated, so you can quickly deploy something, or you can quickly develop something and put it into production. So you are operating in a very high speed manner, which is what a business is looking from technology or technical teams. And the repeatability is really high, because we have automated everything, and then you can take a risk and change anything, because it is highly repeatable. Then the flexibility is really high, because you can take a lot of risks and do changes, because everything is automated and running in a proper flow. And innovation is really high, because you will be you can introduce new concepts without taking any risk. So that is all I have lined. Apologize again for the delay. But I managed to cover everything that I have lined up in the my slides. And these are my contact details. If you like to get any advice or have a discussion with me, you can use my Twitter handler, my LinkedIn profile, and my email address. Feel free to contact me. And if you have any questions, I can spend few minutes and take any questions that you have. If not, you can do contact me via these contact details. So I'll wait for a couple of minutes and see whether there are questions. Looks like there are no questions. So I'll conclude this session. And as I explained earlier, please contact me with these contact details. And then looking forward to talk to you in a future event as well. Have a good day and then enjoy the rest of the sessions in the event. Bye-bye.